Okay. Now I'm ready. No, it's just not coming. It's one of the Myerses. No, one of the Sydney, sorry. It's not Myers, though. It's the other one.
Yeah.
Right? Heinz?
Yeah.
Okay.
Can we do after 2 on the chapter homework 2?
Yes. So homework 2. And you said number 3, you said?
Yeah.
Number 2. Okay. I would do is I'm going to rearrange these equations so that they're in slope-intercept form. So the first equation, we have to subtract the 2x and then divide by a -1. When I do that, I have to make sure I switch. And then this one, we just need to divide by 3. Okay with that? Actually, let me write that in a different color because we'll draw. Now, where did that red arrow come from? That was silly. Okay. All right. So there's that. I'll write a little XY table for each of them. So 0, -4, and then like 1, -2. You're good with how I'm finding the X and Y's there, Sydney? If anybody else has questions, go ahead and interrupt. It's no big deal. For the other one, I get 5, and if I pick -1, I get 3. I didn't pick positive because it would have been off the scale on that graph, but it doesn't really matter. Like even if it's off the scale, you can extend your graph or whatever. It's no big deal. Okay, so I have 0, and this is a solid line, so it's going to look kind of like that, because it's an or equal to inequality is why it's solid. And then because it's a less than, we should be shading below. Okay, well, there's 0, 5, and then -1, 3. Oops, and this one should be dashed because it's a strict. And here we're shading above. And what do we notice here? There's no overlap, right? So these two lines aren't going to intersect, and because one is shaded above and the other is shaded below, there's no overlap even to the shadings, right? So what will we say here? No solution. Yes?
I understand how you get the points for 0, -4, but how do you get the 1?
So what I did is I just picked a value, say for 1, and I plugged it in for x. So 2 times 1 is 2, and then -4 is -2. And then similarly for the other one, I picked -1 for x. So 2 times -1 is -2, plus 5 is 3. Is that okay? And the x's don't matter. I just pick something. You have... I plugged -1 in for x. So 2 times -1 is -2, and then plus 5 is 3. Mm-hmm. Yeah, Mia? Okay. Okay. Sydney, you were done, right? I saw your hand come back up, but we were done with that problem? Okay. I just wanted to double check before I moved on, since I saw your hand come up there. Okay, so you like doing things the hard way, I see. That's okay. Oh. All right, so number 3 you said? Okay. So which equation did you choose to isolate a variable from, and then which variable? So you isolated the x? That would be not the choice that I would make because it gives you fractions, right?
No, yeah, the two.
I would, from an A, I would isolate either y or z, because that's a situation where I won't get any fractions. Or you could have used equation 6 and isolated the y, which again would result in no fractions. It doesn't really, I mean, the fractions aren't a problem other than they make life a little bit more difficult. And my life is hard enough that I don't need any more, like, I need to fight myself and make it harder for me. Is that okay?
Yeah.
Okay, so let's isolate the z from equation 1. So I'm going to add 6x over, add 2y over, and then divide both sides by 2. So that's going to be z equals 3x plus y plus z. Oh, I'm sorry. Minus 8. So far, so good? And then I'm going to take that value for z. Oh, thank you. Thank you. Yes. -4. Thank you. Yes. Good. I'm going to take that value for z and plug it into the other two. So I'm going to take z and I'm going to plug it into b. So that's going to give me, let's do some color coding here. 3x minus 2y minus 4. And then in place of the z, I'm going to put 3x plus y minus 4. And then we have equals 8. And then similarly, we're going to plug z in for c. So when I do that, I have 6x minus 2y minus 6, but instead of z, I'm going to write 3x plus y minus 4. And that's going to equal negative 18. So far, so good, Mia? Okay, so now I'll distribute that negative 4. So I have 3x minus 2y, and I have negative 12x minus 4y plus 16 equals 8. And we'll distribute that negative 6 in the other one. So it's negative 18x minus 6y plus 24, negative 18. So if I combine like terms, I'm going to have negative 9x minus 6y, and then I'm going to subtract that 16 to the other side, which gives me negative 8. Similarly over here, 6x minus 18x is negative 12x. Negative 2y and negative 6y is negative 8y. And if I subtract the 24 over, we have negative 42. So those are going to become my new two-variable system. And here it seems like there's no avoiding getting a fraction now when I do my substitution the next round, but at least I avoided some fractions at first place, right? So if I can save myself a little bit of grief, That's nice. Do we have to make sure there's no fractions? No. I mean, it's fine to do that. But, you know, if you're a masochist or something, who wants to make their life harder than it needs to be? Not this guy, you know? And it's not like dealing with the fractions are really even that hard, per se. It's just like, it's tedious and inconvenient, right? It just slows everything down. All right. So what do you want to do here? I would probably use equation 2, I guess, because everything is even there. And let's maybe get the y by itself. How's that sound to you guys? Okay. So when I do that, I'm gonna add the 12x over, and then divide by -8. So -12 divided by -8 is 3/2. And then -42 divided by -8 is positive, what's that, 6 times 7, so the 2 will cancel out of there, so 21/4. Oops, but that's supposed to be an x there. That's pretty gross looking anyways, but, you know, I guess that's the best we can do. And then we're going to take that, and we'll plug it back in for the y in equation. I guess I didn't label these. I guess we'll call them D and E. So we have -9x minus 6, but in place of the y, we're going to put in 3/2x plus 21/4. And then that's equal to -8. Are we regretting trying to do this as substitution yet? You know, I am. All right, let's distribute the 6 through. Or the -6, I guess I should say. So 6 times 3/2 is -9x. And then 6 times 21/4 is going to be -63/2 equals -8. I do that right. Oops. Oops, 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 oops. Small mistake. It's just a little guy. So I added the 12x over and then divided by a -8. So this should be -3/2. So that should be negative and that should be positive. And what ended up happening here? Oops. Those two things are not equal. We really just have no solution here. Yeesh. Yeah, if you did the elimination, you probably got it much, much faster. I really prefer elimination on these. I don't require you to use it, but boy, if it's me, that's what I would be using every time. I just find it much quicker to use. There's more opportunity to like make your life easier. And there's really, unless the answer has a fraction, unless you get an answer with a fraction in it, you really don't have to deal with fractions ever when doing elimination, which is also speeds things up. Maddie. The same number from the same sheet?
Yeah.
Okay. So I'm just going to go grab another copy of it because I used all the space there. You know what I mean? Actually, let's do this. Let's put it over here. Okay. So Maddie, which variable did you want to eliminate first? Sure, that looks like a good one to me. I don't know why it went back to red there when it was highlighting for a second. Okay, so to do that, what are we going to have to do? Okay, so which two equations are we going to look at first? Okay, so what do I have to do to A? Yep. So we'll cancel out the z's that way. And then what other two equations do you want to use? B and C, okay. So what do we have to do to that one? Close. -6, right? Because they have to be opposite signs. So far, so good? Okay. So let's multiply A by 2. So 2 times -3 is -6. 2 times -1 is -2. 2 times -3 is -6. And 2 times -8 is -16. And then B will just copy right underneath. And then add down. So -6 plus -5 is -11. -2 plus -3 is +1. -6 plus +6 is 0. And -16 plus -4 is -20. So that's going to be my new equation D. Now let's do add B and -6C. So again, I'll just copy B. And then -6 times C. -6 times -6 is +36. -6 times -4 is +24. -6 times 1 is -6. And -6 times 20 is +120. And then we add down. So that's -5, 6 is 31. 3 and 24 is 27. +6 and -6 is 0. -4 and +120 is +116. That'll be my equation E. So far, so good? Oh, yes, thank you. I appreciate the paying attention. These are good things that we're catching. Because as you've noticed, that like one little mistake and you get like a cuckoo crazy answer, right? Okay, good. So this will form my new system now. Okay, which variable do you want to eliminate here? Yeah, that's what I would do also, just because you don't have to multiply both equations. You only really need to multiply one of them, right? So we'll multiply D by -27. Does that sound okay to you guys? And nobody else has seen a mistake, right? If you do, please speak up. Let's see, so -11 times -27 is 297, I think. -27y. And 27 times 20 is 54D. Yeah. And then the other one didn't change. All right, so that's 328 equals 656 And if I divide both sides by 328, that's nice. Look what happens. I get just 2. Righteous. That's pretty promising, right? Who feels good about that? When you get a whole number answer, that usually is a pretty good sign, right? Well, that's a relief. So we'll plug this back up into one of the two places. I would choose equation D, just because the numbers are a little smaller. It doesn't really matter, though. But it's just one of those, like, why make your life harder than it is? So negative 11 times 2 is negative 22, and when I add that to both sides, I get positive 2. Everybody's okay there? And then for my last step, I'm going to take both of these two answers and plug them back into either A, B, or C. I'd plug them back into C. The numbers on X, or the Z coefficient is 1 already, and it just makes life a little bit easier. So that's negative 8 plus Z equals negative 20. If I add, this is negative 20. If I add 20 to both sides, I get Z equals 0. So my answer should be 2, 2, 0. Yeah, we always write them in alphabetical order when we write our ordered whatever. So X, then Y, then Z. Does that feel okay, Maddie? Mm-hmm. And again, to me, that feels much quicker and less to keep track of than the substitution, right? Yeah, and again, doesn't matter to me. If you like substitution, that works for you. That's fine, no big deal. I can do it, I just don't like it. You know what I mean? And I think you should have some choice. If everything does the same thing, why don't I let you choose? You know what I mean? With the two variable one where they're both about the same, there I would make you need to do both of them. But here, they're so long, I don't think I could reasonably ask you to do 2 of these in a test. You know? Anthony. Could I show you how to what? Okay. So what I did, once I had my answers for X and Y, I went back to one of these 3 at the beginning and chose one. I chose equation C. And all I did then was I plugged in the value for X into the X spot and the value for Y into the Y spot. That's what this is right here. And so negative 12 minus 8 is negative 20. When I add that to both sides, I get 0 for Z. Is that what you needed? And again, it doesn't matter which one of those 3 variable equations you chose to use to do the solving. Any of them is fine. I chose C because it looked like the numbers were the smallest. Specifically, there's no coefficient on Z, so I didn't have to do any division. But, you know, it's not usually a big deal which one you pick. They'll all be about the same. Yeah, no problem. Natalie. Sure. Do I have that already? I don't have that one yet. Let's grab that then. Okay. So this is actually one of the easier ones if you know if you realize what you're looking at. So I noticed right away that I don't have an X in the first inequality, right? I have just Y. So if there's no X there, there's really like a 0X. right? So it tells me the slope for that one is 0. So a line with 0 slope is a horizontal line. The question then becomes, where does that horizontal line need to go through? Well, it needs to go through the y-coordinate of 4. So there's the y-coordinate of 4. So my horizontal line just needs to go through there. Is that okay? And then if we're going to have a greater than, we're shading above. I didn't bother with an XY table because it's just a horizontal line. It's no need to do that, right? 1 point is enough if I know it's horizontal. For the second equation, I'm going to go ahead and isolate the x since there's no y variable in that one. So I'll divide both sides by -2. Now, if a y equation or a y-only equation is a horizontal line, an x-only equation should be a vertical line. Where does that vertical line need to go through? Well, it needs to go through the x-coordinate of -3. So there, oops. There's my vertical line. And now there's not an above or below here to think about for the shading, but it's not so bad because here I just need to shade where x's are less than -3. Should that be on the left side of the line or the right side of the line? The left side, right? Or I should say correct. I don't want to say right when the answer was a direction too. And that's it. So our solution is just that corner there up at the top. Cool. And again, it's one of those where like you had to kind of remember what does, like a y equals equation or an x equals equation look like. And it's been a minute since you've seen one of those. I mean, Algebra 1 was a long time ago. I'm sure you did it there, but a long time ago. And if you were a little fuzzy or forgot or weren't sure, like those are good things to ask about for sure. Okay. Anyone else from the homeworks? Sydney, you had a hand up earlier. Did you get squared away on what you needed? Kind of?
Yeah.
What do you want to talk about?
I was confused. I think I figured it out.
Okay. Well, if you change your mind later, you can always ask again. Bill? Sure. Okay. So today, I don't want to do much. We've done a heck of a lot the last 2 lectures, right? We've solved 2 variable systems. We've solved 3 variable systems. We've solved by graphing. We've solved inequalities by graphing. I don't want to do anything really new. What I want to worry about today is 3 variable systems with no solution or infinitely many solutions. That's a situation we haven't looked at expressly. And really the place where I am most interested in is the infinitely many solution situation. I think on homework 5, I think there's 2 of them that come up no solution there. We saw one of them already, Mia asked about. And I think that there's another one in there, if I recall, when I made this up. I think there were 2 no solution problems there. Mia, you're shaking your head at me like that's what I got also, which is probably a good thing. Okay. But we haven't really seen an infinitely many solution situation. So let's do an example of that. We're going to do one example here together, and then we're going to stop, and I'm going to just give you some examples or some problems where that can happen, and we'll just let you practice for the rest of our time in class today.
Is there a way to tell if they're looking at it?
Sometimes yes, oftentimes no. or not a good way. I mean, yes, there's a way to tell, but it's like using linear algebra tools that you don't have any business knowing and using mathematics that we don't know yet. The things that we talked about for a two-variable system still apply. Like if you see one equation that's just a multiple of the other equations, that is a dead giveaway that there's infinitely many solutions. But you can get infinitely many solutions where that's not the case. The reason that can happen, and this is beyond the scope of what I'd expect you to know, but just to illustrate, the equation in three variables, like an x plus a y plus a z equals a constant, is the equation of a plane. It's a three-dimensional or a two-dimensional object. So you can have a situation where you have two planes that are basically identical. That's where you have one that's a multiple of another. But you can also have a situation where like all three planes intersect at the same line. That'll give us infinitely many solutions as well. But it won't look like the equations, it won't be obvious that that's what's happening. So if they are a whole plane overlapping a whole plane, that's obvious to see. It's the same thing as what we saw with the two variable systems, where you had one equation that was just a multiple of the other. But they could get infinitely many solutions where like they're all over intersecting at the same line instead of at a specific point. And there we're going to get, it's not obvious just by looking at the equations without doing some extra work that that's what's going on. Is that okay? So again, that's a good question. And an important one, right? It's because we saw the same thing with the no solution problem that Mia asked about. Looking at that one right away, it wasn't super clear that that was going to have no solution at the equations, right? And the same thing can happen there. You can have no solution where the three planes are parallel. If that's the situation, it's easy to tell by looking at them because you can do it the same way. But you can also have infinitely many solutions where you have something like this happen, where they intersect each other, but not all three of them ever intersect. And that one is, you can't look at the equations and just tell right away using the same method. So there are there's no solution situations that aren't super duper obvious just by looking at things. Is that okay? All right. So let me pull an example here real quick. Okay. Okay. So let's say we have the system x, y plus z equals 7, 3x minus 2y minus z is equal to 4, and x plus 6y plus 5z is equal to 24. So it should be at this point, if you take a look at this, it's not obvious that this would have infinitely many solutions, right? There's no obvious situation where one equation is a multiple of the others. That's okay. So we'll approach this the same way we would normally. I'm going to choose to use elimination to solve this, as it's my favorite method to use. So I'm going to look at the variables, and they're all basically going to be the same in order to do the elimination. I guess the z's seem like slightly less work to me because I have one that's negative and the other two that are positive, and two of the equations are already opposites on the z. That seems like the easiest one to use to me, but it doesn't really make much of a difference. They're not going to be difficult to eliminate. But I'm going to choose to do the z since I have my choice. So to do that, I'm going to do a plus b. That'll eliminate one of them. And then I'll do 5b, 5b plus c. And that'll also eliminate the z's. Is everybody okay with that? We're good with where the 5 came from? Okay. I'm not going to bother writing down a and b again. I'm just going to add them together from the original problem and write the equation there, just to save myself a little bit of time. So x plus 3x is 4x. Y plus negative 2y is just negative y. Z plus negative z is 0. And 7 plus 4 is 11. Either is okay with me. Okay. Raylene, if you want to go to lunch and come back, that's fine. Okay. You're welcome. That's okay. Okay. This other one, though, since I'm changing the equation for b, I am going to write down both equations again and then add them together. So if I do 5 times b, 5 times 3 is 15. 5 times 2 is 10. 5 times 1 is 5. And 5 times 4 is 20. And then I'll write down my equation for c. And add them down. Gives me 16x minus 4y equals 44. So I'm going to take those two together. And that's going to form my new two-variable system. And at this point, you can probably recognize that there is infinitely many solutions now, right? Where it should be easy to see at this point that equation D is a multiple of equation E. So for example, if I just do negative 4 times D plus E, it should be easy to see that I'm going to get 0 equals 0. I'm not even going to bother to write it back out. Is that okay with you guys? You could certainly write that out if you wanted to, but I'm not going to bother to write out the negative 4 times it and do all that stuff. You can. It's not wrong to do that, but you don't need to. Should be easy to recognize that one equation is a multiple of the other there, since the multiple is just 4. Everybody okay there? Now, remember when we solved two-variable systems, I said that this alone, indicating that there's infinitely many solutions, was not going to be enough for me, that I also wanted you to give the parametric solution. So let's talk about how we do that for a 3-variable. Okay? So the first step is to pick one of the two-variable equations. It doesn't matter which one. I would pick this one because the numbers are smaller, but it doesn't really matter. And then I'm going to isolate either the x or the y. Again, it doesn't really matter. For the sake of argument, though, let's isolate the y because I don't have to create any fractions by doing that. So I'll subtract the 4x over and then divide by negative 1. So what that gives me then, since I've written y in terms of x, x is going to be my parameter. to find my y variable, I'm going to do 4x minus 11. Is everybody okay with that? Now to figure out how to write my z variable, I'm going to take my equation for y to one of the original three. It doesn't matter which one of the original three I would use. For me personally, I would pick A because the coefficient on z is already positive 1. It makes the algebra a little bit easier. But it doesn't matter which one of the three you plug it into. They'll all be fine. They'll all, in fact, give you the same result. So I have x plus, but instead of y, I'm going to write 4x minus 11. And then I have plus z equals 7. Since there's no coefficient in front of the parenthesis there, that parenthesis doesn't really need to be there, and I can just kind of ignore it. So I have 5x minus 11 plus z is equal to 7. And now I'm just going to get z by itself. So I'm going to subtract 5x from both sides, and then add 11 to both sides. And that then tells me my way to write z in terms of just x. Is everybody okay with what we did there? Sydney? That's okay. Yep, the 7 is on the other side of the equal sign, right? Good. We're happy with this? Now keep in mind, depending on your choices, you could have had a different answer for this that would be totally acceptable, right? So just for example, if here, instead of getting the y by itself, we had gotten the x by itself, we would have had x equals 1/4 y plus 11/4. So there, the y is our parameter. Right? We have a way to find x, and then to find z, we're going to do the same thing. We'd plug our value for x into one of the equations. I would choose equation 1 again, just because it's oh so simple. So if I combine my like terms, then I get 5/4 y plus 11/4 plus z is equal to 7. I'll subtract 11/4 from both sides. 7 is really 28/4. So 28/4 minus 11/4 is 17/4. And then minus 5/4x. Oops. So there's that answer as well. That is equivalent. And then had we chosen to eliminate a variable instead of y's at our very first step, we could have gotten a version that has z as our parametric. Or I'm sorry, we eliminated z's in our very first step. If we had eliminated x or y first, we could have gotten a parametric answer with z's in it. You do not have to give all 3 versions. Never, ever would I ask you to do that. But there are 3 equivalent answers that are all basically mean the same thing. Okay with that? Okay. We're going to stop here because I want you guys to have time in class to practice on this because, again, we've asked you to do a lot the last couple of days. I want to give you some time in class to practice on things. So I'm going to put in another homework assignment in